Hello everybody, welcome to week 33 now of a lockdown. 33. Sorry I'm late. But hopefully it'll be even better since taking extra time and took the weekend off. So look at this. I pulled this up this morning. It has data up to last Thursday or Friday. What are the trends in the reported date of symptom onset, or aka first test taken in Long Beach? So it's the blue bars you're going to be looking for right there. So what trend do you see? Just tell me what that is. And then this is, I think, 2.5, almost 2 months worth of data. March 6th, April 6th, right before May. So a little over 2 months worth of data. What do you predict for the next 2 or 3 months? What do you think is going to happen? Okay, so go ahead and go back to your sheet, your Google Doc, work on those questions, and then come right on back. See you in a couple minutes here. Or probably take you 10 minutes to come up with some good answers. All right, see you soon. All right, so the trends that you'll see, and it's a little bit tricky because as you may have noticed, the hospital inputs or hospitalizations are mixed with the deaths. So that's gonna, both of those are together make that bar higher. So you gotta really pay attention to these raw numbers here in this diagram or in this graph. So as you can see, a general, looking at these numbers, increase, and then a little bit of a dip, and then kind of an up and down, and then a big spike on April 30th, as you can see. And then it plateaus and dips, kind of goes up and down, and then another, it rises again on April 16th, and then dips, goes up, and really kind of hard to interpret here, kind of goes down, then up, and then down. So you'll see an up. So the basic trends are up and down over just this 2 month time period we see on the graph. We see up and down. Now, what might you predict for the next 3 months or 2 months? Probably based on what you see now, probably see some more ups and downs. If you see people outside like we've been seeing, say on the beaches and whatnot, just in my experience around my neighborhood, 2 weeks ago, most of everybody was wearing a mask. Today, my walk around the block, almost nobody was wearing a mask. And that's a real problem. You guys follow your parents' advice, follow what the governor and our mayor and our LA County leaders are telling us to. If you do go outside, just to walk around, I think it's fine. Just wear a mask and just be careful of how close you're getting to people. But we all need to be in this together. And we're just going to see a big roller coaster like this, and perhaps we could see a big spike if we don't all pay attention. All right, so getting into the work of this week, there is an article that I'm really excited about. I saw this come out 2 weeks ago, I believe. A study from the CDC on a Chicago cluster where they showed how. See, I just saw some spit come out from my mouth. So you definitely need to wear a mask. Luckily, you're not here to breathe that in. They followed a Chicago funeral and a birthday party, and then like a pre-funeral eating, little potluck, and they showed community transmission. Anyway, I want you to read that article. In the article, there's a spot for you to diagram out how the disease spread and write about how it works and different, data from the article. You also are going to do this project planning sheet where you're going to, with household materials, anything you can find, anything, food, utensils in your kitchen, clothing, leaves outside, anything you possibly can come up with, and show how sickle cell disease, the genetics behind it. And then you're going to work together on this group project where I'll put you in groups. You'll see your group, and you'll do a Google Meet just like we've been doing on your own. So I'm going to put that on you. You meet in your group using Google Meet. come up with ideas how you want to divide up the work, just like we might do in the back of the lab stations. Okay. Now, so that's the work of the week. I want to do one more thing with you, and that is kind of just go over the genetics of sickle cell. So we see this is the genetic code, normal. The C's, the A's, and the T's, and they're broken up into groups of 3s called codons. And the main thing comes in this, what is it, the 6th amino acid? Normally you have glutamic acid because you have a CTC here. Now, in sickle cell anemia, this T mutates into an A. And when it does that, the CAC, instead of glutamic acid, codes for valine. And that valine turns these red blood cells into these kind of red blood cells. And you'll see there's some more nuances with it. For example, disease only happens if you get 2 copies of the gene. If you get 1 copy, that's kind of good because you're then malaria resistant. So if you get malaria, if you have some of these red blood cells hanging around from that 1 copy, you're good. If you get the 2 copies, the 2 mutant copies of valine, then it's a problem. You can have some major painful events in your life, sickle cell crisis, organ failure, kidneys and liver, and early death. So that's the basic genetics behind it. I want everybody to know that. Make sure that's in your presentation, and I look forward to seeing it. You guys are gonna really impress me with how well you collaborate online in this new scenario with Google Meet and everything. All right, make sure you attend Wednesday's session in the afternoon, and have fun. Let me know if you have any questions.